So this is our Puma, and our Puma over here is equipped with two valves. This is equipped with two valves. How Jörg was explaining clearly is because that we are going to have two different processes. We are going to have a solder process and a dispensing process with glue. So now you can see that the Puma is doing some test dots before we start measuring the dots and go on action. So right now we have to dispense some small dots and big dots. And the settings that I have over here, it's only for small dot basically, but inside this PCB, what we have over here, we have different kinds of pads, where in this different kind of pads, we need to shoot more dots to simulate the printing process. So we need to put more volume. So that's why, especially for the solar panel, I will explain later what we are going to place, that on the solar panel we need more volume on this particular pad. So now it's dispensing on the big pads right now. It goes on the 0.5 pitch connector. Now after the 0.5 pitch it will jump and do the epoxy. Now we'll pick and place the 01005. So we are placing on the 01005. This is the smallest component right now, it's in the market. And as you can see, it's placing them quite nice, the machine. Now we'll place the 0201s. After the 0201s, we will place the LED and then later on the solar panel. So this is one connector, second connector, LED, and the solar panel. So what we have done over here. So here what we have produced. This is a keychain which we already produced. So here it's the solar panel, where over here we have 01005s. Then there is the LED, which is powered obviously by the solar panel, a connector of 0.5 pitch and a connector of 0.4 pitch. So here you can see that the components are being placed inside our 0.5 pitch, which are here, and 0201s and 01005s, they are over here. So that was we have placed so far. Now let's show only, because the main showing is on the Archer fish, which is our DST valve. Let's show and dispense only with the dispenser, and later on we will check it under the microscope, because the camera over here with the web camera might be it's not visible as good as when we go on a special microscope. So now let's just load for dispensing only. Let's take this one, and yes. So the machine will do eye points measurements. Once again, he will do a process check before we start. This is the process check. It depends on the end user, so he can switch it on or off. For us, since we're doing a test and showing a test, we're showing that the machine can do a process check as well. This will ensure your quality later on, that your quality will be good as well. So we are dispensing on the big pads. Soon followed by the small pads. So you see the two processes integrated together. As soon as the DST has been finished, immediately the glue took over to finalize the glue underneath. So when we place big components, it will be attached properly to the PCB. So let's unload our PCB, and we will take it on our microscope to see what we have done so far. So now we go on our microscope. We adjust the angle. So here, oh yes, we have the dots which are here, what we have produced so far. Let's focus a little bit. So these are the dots. Right, nice. I'd like, yes, this is just to show you on the big pads, what we have done on the big pads. As you can see on the big pads, we did a lot of dots close to each other. So like this, we can fill up a big pad much better. Now we go back. Over here, so let's increase the zoom a bit. Let's take a 3D image. Okay. Yes, nice. So, as you can see here, it's a 3D image of what we have just dispensed. This is around 2 to 3 nanoliters of volume over here. And one has to take in consideration that not only dot size is important, it's important as well the volume. The volume is very important because keep in mind that once the solder goes inside an oven, the flux will be evaporated. So one has to keep in mind that just the volume is very, very important to our process. But here we are showing, which is quite nice process here, nice dot, that we had a very nice dots. And yeah, so let's continue on the machine. So see more capabilities of the machine actually, what we can do. So and the nice of it, the one that we have done, I don't know whether you can see it, but the LED, it's already powering on over here. I don't know whether you are able to see it because there's less light because we're having spotlights, but it's powering on, which is good. It means our process is quite nice. So coming back to my machine, Jörg was explaining clearly as well. Yeah, what we can do more with our machine. So just to show you as well what we can do, we have the Gerber import. What we can do with the Gerber import. The Gerber import today is being most commonly because most of the customers, they are getting files coming with only dispensing processes, where we have introduced as well our Gerber import directly on the machine. So once the customer will have the file, we can just import it on our machine. So I will show how easy it is to import a Gerber file and transfer it to a recipe that later on we can run it on production. So let's see how we can do it. So imagine we have a USB or it's on the network, the machine, we have a file, we just load the file on the machine. Now one has to consider as well that we have various layers. On a Gerber import, we have various layers that one has to think which layer needs to go. Normally we will take the top layer. So voila, here it comes. This is our Gerber import and we have the top layer. Some layers can be defined from here. There will be other different layers. So let's select what we need. So let's assume we will take, because this is our region of interest, and we enable them. Now, as soon as I enable them, it means that later on we just need to group them. So as you can see here, we entered in another menu where we are going to group right now different pet sizes. So for the machine, it will be easier to calculate what kind of dot he needs to put inside. So once I will tell them select all, and I will say group shapes. And group shapes, big shapes, they go together, and small shapes, they go together. Then it will be easier for us later on for the filling. So what remained now? Now it remained that we have to fill those shapes. So I will select all the shapes, and I just tell fill shapes. Sorry. Wow, good. So now, as you can see, the system has filled my shapes, my pads, accordingly. So it tries to fill up as much as volume, how much we gave it, to fill the medium needed. So as you can see, for example, a bigger pad needs more volume. So it needs more dots inside it. Obviously, we can do over there to make it even more faster. Instead of having more dots here, we can have another DST with a larger dot size, and like this we can dispense less dots for our application. But let's go now, and I will explain how easy it is to change from a 200 micron dot to a 500 micron dot, for example. So when you have something like this, so this is the Gerber import where we have done so far, and once I just press the save as recipe, then it's ready where we can start our recipe. So Jörg, if you can pass me the, oh, thank you. So as I was explaining, just we bring the machine off. So this is the DST, what we have said. It's easy to change the fluidic. You remember before I told you that when you have a big dot or a small dot, you cannot run them together. What you have to do is that sometimes you need to change the fluidic part. It depends. This one can, for example, it can take a dot from 200 to 400 micron. But then if you need a 500 to 700 micron dot, you need a different fluidic system. And this is all what you need. And it's much easy. It's very easy. For example, this is to change to a fluidic to a 500 micron dot. So it's easy. No tools required. So we just take the medium and it's out. Everything is on quick release, so it's on special bayonet. Put the new one in and it's done. All you need to do, of course, we have changed the fluidic. All we need to do is that we need to calibrate the Z height, and then we just do a dot over here, which is everything done automatically. We do a dot over here where with the crosshair of the camera we align accordingly the dot. We will show it later on as well. So let's go back now and change back to our fluidic system. Might be I need to change back. How easy. Pipe out, fluidic out, take the other fluidic, plug in, and ready. Now, some people would tell me, oh, but you need to clean it. Yes, you need to clean it, it's true. But don't worry, you don't need to clean a lot of parts. This is the only part that you need to clean, actually. And here I prepared as well for you some parts which you need to clean. So, as you can see over here, with just a simple spanner, these are the parts that we need to clean. So this one, we don't need to clean it actually, but these are the parts that we need to clean. It's very easy to dismantle, very easy to clean, because the ports are not so small as well, and very easy to handle it, and to mount everything back. So I will pass these a little bit to Jörg first. Now, let's show you, the capability of thanks Jörg, the capability of our machine, what we can do with our machine. So, as Jörg was explaining, the machine can handle various kinds of valves, and the valves are easily to be replaced. I will show later on how to replace a valve. For example, this is a time pressure valve, a time pressure where you can mount on every axis on which you want. Then we have this one. This one is the high volume valve where this is good for somebody wants to do. Keep in mind, we are not only in the electronics industry. Some customers, they would have a gasket to seal or underfill or whatever. So this one is for high volume to go sort of a gasket. Then we have here this one, I love it actually because it's fast. You saw it in action. This one is the one over here. This handles a lot the glue, very good, and it's very, very fast. So it's a jet valve as well. And the one but not least, that one, I like it. I personally like it. Why do I like it? Because it's flexible. Okay, the speed is not as the DST or the glue valve, but it's very, very flexible. And this is the micro screw valve, our micro screw valve. And some customers, they are afraid of the micro screw valve. But I will tell you that you don't need to be afraid, especially on the cleaning, because the cleaning part of our micro screw valve is just only this small part here. And as you can see, all the other, there's no need to clean, which is nice. So let's mount it back, and we try to mount it on the machine, so to show you how easy to fix a micro screw valve instead of another typical valve. So let's put this one back. Now, let's take this one. We were going to remove our DST valve. So we take only the plugs out. And connectors are quick release. So, as you can see, the DST is out. Can you hold it for me? Now we will plug our micro screw valve in. And it's ready for action. Once again, it's ready for action. Okay, we need to calibrate the Z height. We need to calibrate the dot position with our crosshair. But as you can see, it's ready for action. Now let's put it back and see the calibration of the dot when we replace a valve, so one can understand better. So in the meantime, yes, thank you. So we put back all our cables, and the cables are very easy to handle. Why? Because they are all quick release and nobody can make any mistakes, because the red goes to red, and they have a location where to go. The blue goes to the blue, and if we have it, like for example over here we have the yellow, it goes yellow to yellow, and we just connect the pneumatics and another pneumatic over here. So our DST is back on its place. Let's calibrate the DST. So we see how we can calibrate our DST now. So we take the DST, calibrate. So here I'm going to show you the one that I was explaining, doing a teach Z height. So it's a physical touch, okay? And then it will, right now, okay, it's waiting for the heater, the valve, to get this ready temperature for this one. Why do we have a heater? The heater is there actually to make sure that here that's our dot. That the process remains stable all the time. So our heaters, normally we tell them that define, and it will do a process check. The heater I was explaining, it's there to keep the process on a stable condition. So it is very, very important that we keep this temperature a little bit higher than the ambient temperature. Then it's much easier for you to the process to continue its stability. So as you can see, the machine, after I did the calibration, it checked itself. So it checked itself, so it checked the dot for 10 times and confirmed that what I did in my calibration, it optimized it to even make it better. Why? Because on the 01005, every micron, it's a little bit more crucial. So like this, we have shown that our teach, it goes good. So let's see whether now we can dispense. So let's take, because we put the board, we will select, excuse me. Yeah, let's see whether we are able. Yeah. So now we have shown that in few easy steps, the machine is cleaning itself, checking for the dot again, confirming the dot, and starts go for action again. So now we have shown that actually after a valve replacement, it's fast to put machine back in production. And now it's back in production for running for us. One can also do this one for the fluidic replacement, even if sometimes the syringe is getting low. To be faster in production, you just can change the fluidic system. So
Kevin,
I will stop now.
you know, guys, it's like that. If we would continue, most probably in 3 hours, he would still talking about his puma, most favorite animal actually. And it's fast like a puma, isn't it?
Yeah.
Great.
Yes, it's fast.
Thank you very much, Kevin. So I will hand over to our product manager, who will give you a little bit more insight of the technical features of the solution.
Thank you very much, Jürgen. Hello, everybody. So let's go a bit more into a few details. Generally, what is actually the motivation of this process of the solder jet printing? So I'm going to show you now a foil in the PowerPoint where you can see there are many points actually which you could use it for. For example, mainly for cost reduction and time to market. So for example, let's talk about where we, for example, do not have a printer available, or we need to do changes. We don't have stencils available. We have product variants as well, could be a possibility. Other possibilities is, for example, for a repair. And it's not only about missing dots on a process. It could be also, for example, for a fully populated PCB where you need to place new components on it, so you can just put our solution into the product into the machine, jet the needed paste, and place then the new component on it. Other nice and interesting things is, for example, the possibility to dispense and to jet into cavities. This is something very special and often needed for special products. Okay, let's go further. The valve itself, this is a so-called DSD technology, a dynamic shockwave technology. So the actuator is pneumatic and is an electronically controlled stroke. The heating is integrated within the valve itself and is controlled by our software. And hereby, it's of course, depending on the paste we are using, on the process we are using, it is saved in the recipe. The fluidic itself is attached by means of bayonet. And Kevin has showed it to you before, that how it looks like. So here we can see that is the yellow part here is the bayonet with the fluidic on it, and can be dismantled like this here, you can see on the picture. So with that possibilities, this fast plug-and-play possibility, you are able to change very fast from one paste, from one product to the other one. It's very fast, the change here you can do. We can also dispense and jet, especially many solder pastes from the market. They need to be, of course, jettable. We are working here with AIM, for example, with Indium, Windot, Interflux, and so on. We are getting there more and more new paste, new kind of paste, new mixtures for new products. So this is a part which is actually moving very fast, and it's very interesting. The most used types is type 5 and type 6 pastes. They're the more commonly used. We could do also higher types or lower types, but it needs to be jettable, and at the end, don't forget about it, it needs also to be solderable at the end. The dot size can vary with our system from 0.1, 0.5, 0.4 pitch, up to 0.8 millimeter. And in volumes, because we like to talk also about volumes when it comes to soldering, it's about from 2 nanoliters, the smallest one we can jet, up to 60 to 80 nanoliters. Everything is possible with this valve and our system. The compatibility of this VDST is with our newer platforms. Now we're going to be into a bit of the Gerber file import, as Kevin told you and showed you on the machine. What the idea behind this concept, this software concept here, is that we actually we simulate a screen printer. Everybody knows how a screen printer means. So for programming that into our software, doing the adaptations is actually quite easy. If you know the process of the screen printer, you can handle it very easy also on our software. The pad filling is automated. You can also decide what kind of filling strategy you want to have. It's possible to adapt either multiple groups of pads, for example, for special component groups or so on, or you can also modify single pads. You can add dots, you can take out dots, you can increase them, you can then smaller, you can do also forms, which maybe don't get from the Gerber file. So with that possibility, you can actually also solder later on very special components, which maybe in a standard it's not that easy. And everything you touch and you change on the in the software, you will see right away in the software screen. Now we're going to talk about some examples we did in the field. Here we have an example of a board with 1,160 components, and if we go a bit more into details, and another product which we did here, for example, to give you an idea what it means to jet print on a PCB, which is, I would say, rather a bit complex, has lots of components. It's rather on the mid-size and high volume components, or solder paste, I would say. So we have here 3,500 dots which we dispensed, and then the dot size were from 400 to 700 microns, and hereby with only one setting it was possible, and changing the parameterization, it was possible to jet this PCB within 6 minutes. Just to give you an idea what it means to jet with our system on this PCB with lots of components on it. Everything what we're doing here, what we are explaining to you, we have of course also on paper. And since there are many solder paste vendors and types on the market, jettable of course, and we have different needs on the PCB side, maybe from very small components, from 01, 05, 04 pitch up to 800 microns. We have defined 3 different settings, and with each setting you will have also the combination with the different pastes. So all this has been tested at our house here in our department, so we know what we talk about. We have the statistics a bit, we have the accuracy, we have the volume, the repeatability, and so on. So we have much experience here, and this list is actually growing because there are coming more and more pastes into the market. So you will also get for each solder paste and application process paper, which will be, and these are available so that you have more information about the process. And now just for an overview about our valves. It's a bit repetition here again. What we have are these 5 main valves that you use. It's a time pressure valve for medium speed, could be rather for medium and high volumes. For medium viscosity, then we have the screw valve. That's the one our Kevin likes the most, because I know why, because it's very versatile. It's not a fast one, but you can really do special stuff with it. You can go also into cavities. You can use it almost for any kind of medium, so the application of it is very, very wide. We have then the volume valve. As the name says, it's rather for larger volumes which you need to dispense within a short time. Then we have our highest speed piezo jet valve, which we're using for mainly for glue applications. And then the one which we just showed, the VDST, our solder paste jetter for our solder paste, of course. Good. and I will